Sometimes when working with radicals, it's easier to write the radical expressions as exponential expressions. If you don't know how to do that, keep watching. Welcome to Math Bytes, I'm Allison, and today we're talking about radicals and rational number exponents. If I write the square root of x, we don't normally write that little 2 in there to indicate that it's a square root, it's just implied. But if I want to write the cube root of x, I put the little 3 in there. 4th root of x, I put the 4 there. The 5th root of x, I put the 5 there, etc. Now we can write these radical expressions with rational number exponents. Remember, a rational number is an integer over an integer. So the square root of x is the same as x to the power of 1/2. The cube root of x is x to the power of 1/3. The 4th root of x is x to the power of 1/4. The 5th root of x is x to the power of 1/5, and so on and so forth. So we can express these radicals with rational number exponents. Here's a definition for you. M and n are positive integers, and m over n is in lowest terms. B is a real number. B to the power of m over n is equal to b to the power of 1 over n, and that whole thing raised to the power of m, or b to the power of m and that whole quantity raised to the power of 1 over n. So you can either take the root first and then raise to the power, or vice versa. Let's look at an example. 8 to the power of 2/3. Okay, so that's 8 to the power of 1/3 and that whole quantity squared. 8 to the power of 1/3 means I take the cube root of 8. So I want the number that multiplied by itself 3 times gives me 8, and that number is 2. So 8 to the power of 1/3 is 2, and I have to square that, and I get 4. Okay, let's do it the other way. 8 to the power of 2/3 is equal to 8 squared, and then we take the cube root of that whole quantity. 8 squared is 64. The cube root of 64, the number that's multiplied by itself 3 times to get 64, is also 4. So as you can see, it doesn't matter which way I do it. If I do the root first or the power first, you will get the same answer. So you do whichever one's easiest. All the properties that we use for integer exponents also apply to rational number exponents. So for example, if I have 2 to the power of 1/3 times 2 to the power of 2/3, I'm multiplying, so I add my exponents. That becomes 2 to the power of 1/3 plus 2/3. If I have 8 to the power of 1/2 divided by 8 to the power of 1/4, because I'm dividing, I subtract my exponents. So I get 8 to the power of 1/2 minus 1/4. If I have 3 to the power of 2/3 and that whole quantity is cubed, now I multiply my exponents together. So I get 3 to the power of 2/3 times 3. And if I have, for example, 9 over 4 to the power of negative 3/4, I can make that exponent positive simply by taking the reciprocal. So that's equal to 4 over 9 to the power of positive 3/4. So all the usual properties still apply. Let's make sure it's clear how to go back and forth between a radical expression and an expression with a rational exponent. So if I have the nth root of b to the power of m, that is equal to b to the power of m over n. And if I have the nth root of b and that whole quantity raised to the power of m, that's also equal to b to the power of m over n. So your power goes in the numerator of your exponent, and your root goes in the denominator of your exponent. And as long as you keep that straight, you can go back and forth between a radical expression and an expression with a rational exponent. Think of it this way. Rational number exponents give you all the fun of exponential expressions with the added fun of working with numerators and denominators. And who doesn't love that? That's it for this episode of Math Bytes. If you like our videos, please subscribe to our channel. And if you have a question you'd like to ask us, just send us an email. We're at contactmathbytes@gmail.com, and I will see you next time.